Ladies and gentlemen, welcome back. I'm going a little bit off script today. For once, I am finally have enough free time that I can start talking to my friends who are in Algebra 2 Goal 3. The vast majority of whom are already in like the upper 70s and 80s. They're only a couple of topics away from finishing, and those are the ones that I low-key want to focus on. These videos are going to be a little bit smaller than some of my other ones because I want to focus and narrow in and making sure that I'm doing very specific topics for you, ladies and gentlemen. So, first things first, this is probably the most important video of the bunch because these topics here that I'm going to be doing, finding the final amount of a word problem using exponential growth and decay in its various permutations. This is, I think, a grand total of 3 questions on the DSA, and this is also on the PA. So this is the formula you need to know the most. Like, I cannot tell you this formula on the test or the PA. You have to be able to do this under your own power. So let's zoom in a little bit and tell you guys what you need. So, final amount of a word problem and an exponential growth and decay. This is the light version of the topic, and then there is a we'll call it a gray version of the topic. Nothing is even medium or even hard for this. What's going to happen here is I'm going to cross out one of the variables and then rewrite this. So A equals P parentheses 1 plus R over T. And here's what all of these things mean. P is your principal. What this means is this is your starting amount. Rate is your actual percent. And then you want to take your percent and then you want to convert it to a decimal. And we're not talking about that's in the other topic. And T is time in years, and also just once in a while they're going to give it to you in half lives. What you're doing is that you're always going to have a calculator handy with you, okay? And as you're going through it, you're going to basically, once you have your formula written down, all you're doing is funneling it into the calculator and letting the calculator spit out your numbers. So I'm going to put this one on pause. We're going to call this one number 2, and we're going to do this one as number 1 first, just so that I can get you comfortable with the formula first. So it has a population of 220,000 people. That's your starting amount, okay? It grows by 6.75%, and then there is our time. And those are the 3 most important numbers we need. So our answer is going to be, what's our starting amount? 22,000. And then it's 1, because you see here, the 1 is always going to be there. So therefore, we're going to put a 1 here. Then the question is this growth or decay? This is grow, so that means it's going to be plus. What's our rate? We're going to take our 6.75. That's the percent. We need to convert it to a decimal, so I'm going to take my decimal and move it over 2 places. So 0.0675 to the power of how many years? 6. So let's pull out a calculator and see what kind of number gets spat out. Before I start talking about the calculator, make sure this was for 2 topics you're going to be told to round 2 different places. So for this topic, you're rounding to the nearest whole number. That's what we want to keep in mind. Nope. That's what we want to keep in mind. So when we're doing this out, if you're using your phone calculators, you know, the ones that look like, make sure you turn your calculator sideways so that they look a little bit like this, all right? So what we're going to do is, what is 1 plus 0.0675? So 1 plus 0.0675 equals. Okay, so that makes sense. This, but where is it? Where'd it go? This button right here is your exponent button. So it's to the power of how many? 6. There's our answer, times 22,000. Boom, done. So what is our answer? 32,555,9. 32,555,9. And do we round the 9 at all? 0.2. No, we don't. Like, literally, that's it. That's all you're doing for this. Do they give us another one? Yes. So what's our starting amount? Our starting amount is 4,200. Okay. This is banking. So banking is always addition. So plus 0.045. Because remember that 4.5, I moved the decimal over 2 places. And then how many years? 13. So I have to do this part first. 1 plus 0.045. So 1 plus 0.045 equals. to the power of 13 equals, and then times 4,200. I'm done. There it is. 7443. 7443. That's how fast this topic kind of goes. The only thing to keep in mind of, like I had talked about before, is that they do have one topic that's written really weird, and that's what this topic is. And I found a screen grab of it, so I grabbed it immediately. So here, the numbers you're looking for aren't completely there. Like, you're starting with 120, so that makes sense. It's 120 something. But, like, where's the percent? I don't see that anywhere. And it's half-lives. How does that logic? Like, what? But that's why I wrote things as I did. So if we're going to scroll up a little bit here, a half-life is our years. So if it's 3 half-lives, that's where the 3 is going to go. Now, if you remember from science, and Mr. Millikan will be ashamed of you if you don't actually remember this, radioactive isotopes, the whole point is that because they're radioactive, you want the radiation to go away, right? You want it to reduce, which means this is going to be subtraction. And very specifically, they actually kind of sneak in exactly what you're looking for immediately. Because if you want half of, you're decreasing by half. That's what a half-life means. How long does it take before half of your material has finally dissipated and disappeared? So if it's a half-life, what is half as a fraction? 0.5. There you go. That's low. I'm not going to say it's low-key easy. I almost did. It's not as easy because the wording is a little bit awkward and it expects you to remember science stuff. So, make Mr. Millikan proud. Remember that half-life means you're decreasing by half because that's the whole point of radioactive isotopes. So, 1 minus 0.5 is just 0.5. So, 0.5 to the power of how many? 3 equals. And then we're going to multiply it by our 120 grams. And there's our answer, 15. 15. They actually gave you a nice one. So that's what this formula does, and that's what exponential growth looks like. It's actually pretty straightforward as a result of that. But what happens if you have this, the n that we had talked about earlier? All right, so here we go. Here is what we're going to talk about with our n. What this means, you can tell your keyword because it's going to be compounded. That's the keyword you're looking for. Now, a couple of things first. When you're dealing with compound interest, this is always going to be a plus. Always a plus. Where up here, you could see it was either plus or minus, depending on whether they told you the word grow, half-life, or sometimes they'll outright tell you decay. Back over here, however, it's always going to be a plus symbol because banking is always addition. And since it's banking, there's only 4 real words that you're going to get for these. When you're compounding, you're either going to compound it annually, oh, computer, don't do this to me. Annually, or you could do it semi-annually, annually, or you could do it quarterly, quarterly, or you could do it monthly. And you have to remind yourself what these words actually mean. So annually, what things are annual? That means they're held once a year. Semi-annually, semi is half, which means you're holding it every 6 months, which means you hold it twice a year. Quarterly, that tells you it right in the name, how many quarters are in a dollar, 4, and monthly is going to be 12 because there are 12 months in a year. And low-key, if I can tease more than one student in the annals of me teaching this software, I have had kids tell me monthly is 1. Please don't do that to me. Monthly is 12. So, start ourselves up. We're going to write. Now, keep in mind for our rounding, because this is money, we're rounding to the nearest cent. So that means 2 decimal places. So what's our starting amount? It is 2,000. Okay. This is a 1 because we always put in a 1. And then it's adding because it is banking, it's addition. And then 15%, so I'm going to take my 15% and move it over 2 places to 0.05. It's compounded monthly, so divided by 12. 12 times what is my years? 5. And notice, the 12, my compounding was used in 2 different places. and that's because n itself is used in two different places. You're shocked, I can tell. So for the phone calculators, this is a little bit trickier. You want to do some computation first, okay? So 0.15 divided by 12. 0.15 divided by 12 is that mess. So it'll be 2,001 plus, and I've already forgotten the number, 0.0125. 0.0125, and then 12 times 5 is 60. So that'll be 2,000, 1 plus point, so 1.0125 to the power of 60. That's what I'm inputting into the calculator. So 1.0125 to the power of 60 equals that unholy mess times 2. And what do we have? 4214. Okay, 4214. And then what's my decimal? 36 or 37? 36. 36. And that's going to be our final answer. And you realize, other than being a little bit more careful with the calculator, this actually isn't that bad. And we go through it again. So we suppose 2,000 is invested again. 2,000. 1 plus 3.7, move it over 2 places, so it's 0.037. Compounded semi-annually. What number is semi-annually? Let's look that up. Semi-annually is 2. 2 times 6 years. So what's 0.037 divided by 2? 0.037 divided by 2 equals 0.0185. So 2,001 plus 0.0185, and then 2 times 6 is 12. So 1.0185. Computer. Sorry for the unexpected lag. My computer started to overclock and I had to wait for everything to catch up. So 0.185. So where are we? Okay, so 1.0185 to the power of how many? 12, okay, times 2,000, and what do we have? 2492.08. 2492.08. Did I copy that right? 2492.0808. And you're starting to realize that this is just as easy as the first topic. So what's our starting amount? 2,000. Boy, they love 2,000 as a starting amount. Wouldn't we all love to have that kind of money? This is ed banking, so this is addition. 10%, move it over 2 places, compounded annually. So that's once a year times how many years? 10. Now I can cheat a little bit here because I happen to know that 1 doesn't actually affect any of the computations. Divide by 1 doesn't change anything, and 1 times 10 doesn't change anything. So this is 2,000, 1.10 to the power of 10. Okay, so 1.10 to the power of 10. Enter. Times 2, 1, 2, 3, and what do we have? 5187.48. So 5147.48. I know I didn't copy that right. 5187.48. 87. Silly Miss Dubois. 5187.48. So obviously be careful when you're copying and pasting your numbers. One last thing, 2,000 to start again. Why did all of these end up being 2,000? They're not all, are they? Then plus. It is 18%. Move the decimal over 2 places, so 0.18. Quarterly is 4 times a year, so 4 times 6. So 2,001 plus, I don't know what that is, but 4 times 6 is 24. So what's 0.18 divided by 4? 0.18 divided by 4 is 0.045. So 0.045. Okay, so what does that mean? We have 1.045 to the power of, nope, that didn't work, escape, clear. So it'll be 1.045, there we go, to the power of 24 equals times 2, 1, 2, 3, and what do we have? We have 57, 52, 03, because the 7 makes me round up, and that will be an 03. So 57, 52, 03. 57, 52.03. And there's our answer. So, what we have learned. We now know 2 of the last topics you need for Goal 3. They are DSA and PA topics, very, very important. I say yet again, I cannot give you the formula for the DSA and the PA. You have to be able to come up with it under your own power. So, next video, if I have time for it, we're going to be talking about the last 2 major DSA topics, this one and this one. This one tends to 9 times out of 10 you need to unlock something first, so that means that in my next video we'll have 3 topics to talk about instead of 2. And then we will talk more after that. Stay happy, stay healthy, stay safe. See you in the next one.